A jar is supposed to contain 24 ounces of peanuts. The filling machine inevitably experiences fluctuations in filling, so a quality control manager randomly samples 12 jars of peanuts from the storage facility and measures their contents. And these are the samples that we've been given. Okay, part A is define a standard deviation. So in order to do that in our calculator, we're going to go to Stat, Edit, and then we're going to look to just figure out if you have anything, but we're just going to input our numbers. So 23.93. Once we have that in, we're going to go to Stat, Calc, and we're going to do our 1-var statistics for list 1. So if we calculate that, since this was given from a sample, we're going to be looking at S. So we have that S is equal to 0.3718. All right, so now that we have the standard deviation for the sample, what we want to do is use that to construct a confidence interval for the population standard deviation. So here we're going to be using the formula that in general sigma squared is equal to n minus 1 s squared over chi squared, where chi squared is the number from our calculator, those critical values given from the calculator. So we're doing a 95% confidence interval. So on my chi-squared distribution, that means we have the middle 95%. And we're not necessarily symmetrical, but we have 95% here. So that means left over we have 2.5% in each one of these tails. So 2.5% and 2.5%. And what we want to find are what are these two values or critical values from the chi-squared distribution. And remember, when we plug into our calculators, we're always plugging in the area to the right of that point. So this would be 95% plus 2.5%, so 97.5, or chi-squared 0.975. Likewise, from this point, that would be 2.5%, or chi-squared 0.025. Okay. So in order to figure out what these actual critical values are, we're going to take these numbers and plug them in using our chi-squared program. So hopefully you've seen that program tutorial. If not, please look at this in the modules, but we're just going to go to Program, Chi, press Enter. The first thing it asks for degrees of freedom. We have 12 jars, so the degrees of freedom is always one less, so we have 11. And we're just going to input these numbers. So chi-squared 0.975. Give this a second to calculate. And we have our first value, which is that chi-squared is equal to 3.816. So that represents the critical value on this first point. And then on the second point, same thing, we're going to program chi again. Degrees of freedom is still 11, and here we're working out the area of the other term, which is 0.025. All right. So we have chi-squared is equal to 21.92. All right. So in order to generate our confidence interval, we're going to use the formula that in general sigma squared is, as we said, n minus 1. So in this case, we're going to plug in 12 minus 1. My standard deviation, we calculated earlier to be 0.3718 squared, all over, and then we're just going to go over these two values. So the first one is 21.92, and then that'll give us the lower bound, and the upper bound will be 12 minus 1 times 0.3718 squared all over 3.816. So we throw these into our calculator. And this gives me the first value of 0.0694. And if we do the exact same equation, but using the other value of 3.816, we get the second value. And once again, these are technically the variance sigma squared. So 0.3985. So the last step here is we want to take the square roots of these values because we have sigma squared. We want a confidence interval for the standard deviation sigma. So my last step is we're going to take a square root of both these numbers. So first one is going to be a square root of 0.0694, which gives us 0.2634. And then on the other end, square root of 0.3985 gives us 0.6313. All right, so there we have our confidence interval. So as an interval, we have 0.2634, 0.6313. Or, in words we wanted to interpret this, we are 95% confidence that the population standard deviation of the peanut jars is between 0.2634 and 0.6313 ounces.